All right, it's going to be important for us to get quick sketches of graphs. So let's find out what the change is if I take a function and if I add c to it. So like this, if I know the graph of y equal x to the fourth is basically like a parabola. So then y equal x to the fourth plus 1 will shift it up by 1. I know what sine of x looks like. Sine of x here goes between 1 and -1. I'll just draw one period of it. Starts here, goes up to 1 and down to -1. So that's just good old sine of x. So if I want to graph sine of x plus 2, it will now start up here at 2 and go up to 3 and then down to 1. All right, this here, I'm going to be subtracting a c off, so I'm going to be subtracting a number off. So you know that y equal x to the 2/3 looks like this. So y equal x to the 2/3 minus 1 brings it down by 1. 1 over x, the basic graph looks like this. So it's important that you know it's got asymptotes here and an asymptote here. So subtracting 3, we'll move this horizontal asymptote down to -3, and now the graph will look like this. All right, so subtracting a constant on the inside of a function, minus c, like this, -4 on the inside. So you know the regular root x graph looks like this. So y equal root x minus 4 shifts it to the right by 4 units, so it looks like this. You know the graph of ln of x looks like this, has an asymptote here. Asymptotes are a really big deal. You should know where those are. So then to graph this, it will move it to the right by 1, so now the asymptote will be at the number 1, and then this will cross at 2, used to cross at 1. If I have on the inside of a function added on, like here, I would take my basic graph of y equal x cubed, looks like this, and I'm going to move it to the left by 2, so it'll look like this. I know that the basic graph of 1 over x squared looks like this, asymptote here and here. So now with an addition of 4 on the inside, I'm going to move it to the left by 4. So now the vertical asymptote is here. It still has a horizontal asymptote here. And so this would be the basic shape of the graph. All right, so if I have a negative on the inside of a function, so what that does is it reflects it about the y-axis. So there's your basic graph of ln of x. So y equal ln of -x is going to be back here like this. I know that the graph of e to the x looks like this. So the graph of y equal e to the -x is a flip over the y-axis. So it still goes through the point of 1. A negative in the front reflects it about the x-axis. So you know that the basic graph of x to the 1/3 looks like this. So y equal -x to the 1/3 will look like this. You know that the basic graph of root x looks like this. So y equal -root x would be down here like this. All right, so basic facts about odd and even functions. So an odd function is if you plug in a -x and you get the negative of the f of x out, and it's even if you plug in a -x and you get the f of x out. So if it's even, I think you all are familiar with y equal x squared. That's an even function. A function that looks odd is y equal x cubed. So most functions are neither odd or even. So let's check to see that with this one. So you substitute in a -x, you do the operations, and this gives us x to the 4th plus 2, which is the function. So here I have f of -x is f of x. So that means that it's an even function. This here, if I substitute in -x, and I cube my negative x, I get negative 2x cubed. So this is equal to negative f of x. So that means that this function is odd. If I substitute in negative x, this gives me a negative times a negative, so that gives me a positive x cubed plus an x squared. This is not f of x, and it's not negative f of x. It's neither, so it's neither even or odd. So keep in mind what it means to look even, like y equal x squared, and what it looks to be odd, like y equal x cubed.